Let's have some fun with graphs. It's always good to make pretty pictures out of your work, and this will give you some more tools for visualizing different types of data. Using different types of graphs, making it look pretty, use different colors, different line styles, different axes, things like that. So it's not only important to use graph and data visualization to try to find interesting things in your data, but it's also just going to present your findings well to a non-technical audience. So let's dive into Matplotlib. Go ahead and open up the Matplotlib Python notebook so you can play around with this stuff with me. We will start by just drawing a simple line graph. So in this example, I am going to import a matplotlib.py plot as plot, and we will just refer to its plt from now on in this notebook. And what I am gonna do is use numpy.arrange to create an x-axis filled with values between -3 and 3, and our commencement 0.001, and I am gonna use pyplots plt function to plot x, and the y function will be norm.pdf of x. So I am gonna create a probability density function with a normal distribution based on the x values, and I am using the scipy states non package to do that. So trying it back about probability density functions, here we are plotting a normal probability density function using my Matplotlib. So we just call the pyplot plt method to set up our plot, and then we display it using plt.show, and when we run that, that's what we get, a pretty little graph with all the default formatting. Let's say I wanna plot more than one thing at a time, so you can actually call plt multiple times before calling show to actually add more than one function to your graph. So in this example, I am calling my original function of just normal distribution, but I am then gonna find and render another normal distribution here as well, with a mean around 1.0 and a standard deviation of 0.5, and I am gonna show those together and how they compare to each other. And you can see by default Matplotlib chooses different colors for each graph automatically for you, which is very nice and handy of it. There you have it, and if I wanna save this to a file, maybe I want to include it with you, I can do something like this. Instead of just calling plt.show, I can call plt.savefig with a path to where I wanna save this file and what format I want it in. So in this example, I have the same plot, but instead of show, I am calling savefig to that file, and you will wanna change that to an actual path that exists on your machine. If you are following along, you probably don't have a user frank on your system, and remember too, if you are a Linux or Mac operating system, instead of a backslash, you are gonna use forward slash, and you are not gonna have this. So with all of these Python notebooks, whenever you see a path like this, that's sure that you change it to an actual path that works on your system. Okay, but I am on Windows here, and I do have the users backslash frank, and I can go ahead and run that. So if I check my file system under users slash frank, sure enough I have my plot.png file I can open up and look at, and I can use that in whatever document I want. So pretty cool. Alright, let's move on. Let's say I don't like the default choices of the axis of this value, like it's automatically fitting it to the tightest set of axis values that it can find, which is usually a good thing to do, but sometimes you want things. In this example, I am setting the x limit using First, I get the axis using plt.axis, and once I have these axis object, I can adjust them. So by calling set x lim, I can set the x range from -5 to 5, and set y lim, I set the y range from 0 to 1, and you can see that down here my x values are ranging from -5 to 5 and y goes from 0 to 1. And I can also have explicit over where these tick marks are. So I am saying I want the x ticks to be -4, -3, etc., etc., and y ticks from 0 to 1 at 0.1 increment. Now I could use the arrange method to do that more compactly, but the point is you have explicit control over where exactly those tick marks happen, and you can skip some. You can have them at whatever increment or whatever distribution you want. Beyond that, it's the same thing. Once I have adjusted my axis, I just call plt with the function that I wanna plot, and call so to display it. Ensure there you have the result. What if I want grid? Well, same idea. All I do is call .grid that I get back from pyplot.axis, and by doing that I get these nice little grid lines, and that makes it a little bit easier to see where a specific point is, although it clutters things up a little bit, so a little bit of a stylistic choice there. What if I wanna play games with the line types and colors? You can do that too. So you see here, that's actually an extra parameter on the plot function where I can pass a little thing that describes the style of a line. And at this first example, what this indicates is I want a blue line with a solid line. That's what the B stands for, blue, and the dash means a solid line. And for my second function, I am going to plot it in end. That's what the R means and the colon means. I'm gonna plot it with little vertical hashes all the way up. If I run that, you can see that's what it does, and you can change different types of line styles there. In addition, you can do a double slash or a double dash rather, and that gives you this dashed line as a line style. I can do a dash dot, and you can get something that looks like that. So those are the different things, or I could make it green with vertical slashes, and there you go. So have some fun with that if you want. Experiment with different styles and you can get different line styles. Something you will do more often is labeling your axis. You know, you never wanna present data in a vacuum. You definitely wanna tell people what and to do that you can use the x label and y label functions on Pyplot to actually put labels on your axis. So I am gonna label the x-axis greebles and the y label probability, and you can also add a legend inside here. Normally this would be the same thing, but just to show that it's set independently, I am setting up here a legend, and you pass in basically a list of what you want to name each graph. So my first graph is going to be called snitches. My second graph is going to be called gags, and the loc parameter here indicates LOC parameter what location you want to it. Therefore represent the lower right hand corner. And so let's go ahead and run that. And you can see that I am plotting greebles versus probability for both snitches and gags. A little doctor's use reference for you there. So that's how you set axis labels and legends. Little fun example here. If you are familiar with the web comic XKCD, there's a little bit of an Easter egg in XKCD style. And you can do that by calling plt.xkcd, which kind of puts Matplotlib in xkcd, and after you do that, things will just start to look, like this styles of kind of a comic book, that and squiggly lines automatically. And this little simple example shows a funny little graph here where we are plotting your health versus time, where your health takes a steep decline once you realize you can cook back on whenever you want it to. And all we are doing there is using this xkcd methods to go into that mode. Little bit of interesting Python here in how we are actually putting this. So we are starting off by making a big data that is nothing but the value 1 across 100 data points, and then we use the old Python list slicing operator to take everything after the value of 70, and we subtract off from that sub list of 30 items the range of 0 through 30, so that has the effect of subtracting off a larger value linearly. So as you get past 70, which result in that line heading downward down to 0 beyond the point 70. So a little example there of some Python list slicing in action there, and a little creative use of the arrange function to modify your data. Now going back to the real world, we can remove xkcd mode by saying rcd faults on Matplotlib, and we can get back to normal chart here. If you wanna go this, all you have to do is call plot.py and give it an array of your values, colors, labels for pie chart, or whether or not you want items exploded, and if so, by how much. So you can see here I am creating a pie chart with these values 12, 55, 4, 32 and 44. I am going to assign explicit color 14 to each one of those explicit labels. To each one of those labels, I am gonna explode out the Russian segment of the pie by 20%, and I am gonna give this plot a title called student locations and show it, and that's all there is to it. If I wanna do a bar chart, also very simple, kind of a similar idea to the pie chart. You give it an array of values, an array of colors, and you just plot your data. So I am telling it to plot from the range of 0 to 5 using these y values in this array and using this explicit list of colors. Go ahead and show that, and there you have your bar chart. And a scatter plot. This is something we will see pretty often. So say you have a couple of different attributes you wanna plot for the same set of people or things. For example, maybe we are plotting ages against income or something for each person, where each dot represent a person and these axes represent different attributes of those people. The way you do that with a scatter plot is you call pie plot with a scatter using the two axes. That you want to define the two attributes that contain data that you want to plot against each other. So let's say I have a random distribution in x and y, and I scatter those on a scatter plot and I show it. This is what it looks like. Pretty cool. So you can see this sort of a concentrations in the center here because of the normal distribution that's being used in both axes, but since it's a random, where there is no real correlation between those two. Finally, you will remind yourself how a histogram works We have already seen this plenty of times in the course, but if you are just call, for example, a normal distribution centered on 27,000 with a standard deviation of 15,000 with 10,000 data points, I can just call piplots histogram hist function, and you specify the input data and the number of buckets that you want to group things into in your histogram, and do this call so, and the rest is magic. Finally, box and whisker lecture. So remember, in the previous, when we talk about percentiles, I touched on this little bit. Again, with the box and whisker plot, the box represents the two inner quartiles where 50% of your data resides, and conversely another 25% resides on the other side of that box. But these dotted line whiskers represent the range of the data except for outliers. So we define outliers in a box and whisker plot as anything beyond 1.5 times the inner quartile range or the size of this box. So we take the size of that box times 1.5, and up to that point, that's what we call these outer quartiles, but anything outside of that and considered an outlier, and that's what these lines represent here. That's where we are defining outliers based on our definition with the box and whisker plot. Now, just to give you an example, here we have created so fake data set where we have a uniform random distribution of data, and then we add in a few outliers on the high end and a few negative outliers as well, and then we can catenate those lists all together and create a single data set from these three different sets that we created using NumPy. We then take that combined data set of uniform data and a few outliers, and we plot it using plt.boxplot, and that's how you get a box and whisker plot. Also, to visualize it, and you can see that it's showing that box that represent the inner 50% of all data, and then we have these outliers lines where you can see little crosses for each that lies in that range. Alright, that's Matplotlib, your crash course. Get your hands on it. Actually, do some exercise here. As your challenge, I want you to create a scatter plot that represent random data that you are fabricate on age versus time spent watching TV. You can make that anything you want, really. If you would like to play with some fun with it, or create a scatter plot that plots two random sets of data against each other and label your axis. Make it look pretty, play around with it, have fun with it. Everything you need should be in this Python notebook that you need for reference and for example. But if you have any trouble, feel free to write in our comment section.